Hey everybody, it's Mr. Roy. Today I had you working in groups to complete that Microsoft Forms quiz together. It had some pretty tricky problems on there. So that's representative of some of the tougher stuff by far that you're going to see. And I wanted you to challenge yourselves and challenge each other, but I want to go through those questions now in case you wanted to see solutions to them. I'm going to go kind of fast, so if you want to slow things down, well, there is a way on YouTube to slow the video speed down, and I'll start talking like this. But I want to just jump in and take you through how we would solve these. Of course, you can fill the thing out yourself and just hit enter and do it as many times as you want, and you'll be able to see what the correct answers are. But I wanted to take you through how we actually would solve these. So for our first one, the correct answer is 28, and here's how we're going to get there. What's the 10th term of the sequence? Well, when I look at this, I can tell just quickly by looking at it that I'm adding 3 each time. So this is an arithmetic sequence. My first term in this arithmetic sequence is a 1, and my common difference is a 3. I'm going up by 3 each time. I'm going to write my general term for my arithmetic sequence. It looks like this. This is kind of the formula for an arithmetic sequence. And now I'm going to sub in my values for A and for D. So here we go. My A is 1. My D is 3. I'm going to multiply that 3 through the brackets. I'm going to collect my like terms. And there's my general term for this arithmetic sequence. Okay, so now that I got my general term, it makes it really easy to find any other term. So to get the 10th term, well, that's simple. All I need to do is sub in a 10 anywhere I see an n in my general term. So 3 times 10 is 30 minus 2. Our 10th term is going to be 28. Okay, so that's how we got there on that first one. Awesome. Let's move on to our next one. Here's number 2. It says the 11th term of a sequence is 24. If the first term is 374, what is the common difference? Now this is worded in kind of a slightly weird way to make it a bit more difficult. The first term, we also call A, is 374. Okay, I know it asks for a common difference, so that tells me we're talking arithmetic sequence. The 11th term is 24. So my common difference is negative, right? It's going down. But I don't know actually by how much each time. Some amount to get it from 374 all the way down to 24. Okay, so let's see how we figure that out. How many jumps are there between the first term and the 11th term? You may be tempted to say there's 11, but there's actually 10. Count them up. You're starting at 1, and then you jump 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So to get 10, 11. So to get to the 11th term from the first, that's 10 jumps. And each jump is we're taking off that common difference 1 time. So 10 times our common difference gets us there. So if we subtract our 2 terms, the 11th one and the first one, and see what their difference is, and then we divide it by 10, that'll tell us what the difference of 1 jump would be. So the 11th term is 24. The first term is 374. So we end up with 350 equals 10 times D. Divide both sides by 10. We're going to end up with 35 equals the common difference. Oh, sorry, there should be a negative in there. Because 24 minus 374 is minus 350. So the answer should be minus 35, which makes sense, right? Because we're going down. So that's going to be our common difference, minus 35. Each jump from the first term to the 11th term, we go down by 35 each time. And that's what gets us there. Okay, rolling on. We're doing great. Let's check out number 3. I don't actually know for this one if it's arithmetic or geometric because it doesn't say. I can tell it's going down, but is it going down by a common ratio or is it going down by the same amount each time? Is it going to be arithmetic or geometric? Common difference or common ratio? I can't tell. So let's start just by subtracting some terms. Let's take the, I don't want red marker. I want purple marker. Okay, so let's take the, I don't know, the 4th term. and subtract the third term, the one before it, and see what we get. That's going to be 2615 minus 3490. And I get negative 875. That's the difference between them. Let's see if it's a common difference. Let's see if another group of two terms right next to one another has the same difference between them. 4365. That also has a difference of 875. Okay, and so you can see the difference between each of them is actually negative 875. So D, our common difference, is negative 875, and this is arithmetic. Our first term is 5240. Okay. So that's all I need to know to get my general term for my arithmetic sequence, is the first term and the common difference. So let's write my general term. General term is a plus n minus 1 to the power d, or times d rather. My first term is 5240. Common difference is negative 875. Okay, let's multiply that negative 875 through the brackets. Okay, multiply through the brackets. Negative 875 times n is negative 875n. Negative 875 times negative 1 is positive 875. Okay, let's collect our like terms. We've got some regular number here and a regular number here. Let's collect those like terms together. So we're going to end up with 6,115 minus 875 times n. That's our general term. That would allow us to find any number in there. But we want to find how many terms are in this sequence when we've got a whole bunch missing in the middle. So we're going to use our general term in a slightly different way. I'm going to put in my general term my last number, and I'm going to figure out what the n is for that one. So I'm just using my general term just as I just wrote, minus 875n, and I'm going to solve for n. So I said for this number, which is right here, it's my last one, what's my n? N1 would be the first term, N2 would be the second term, N3 would be the third term. What is it, N20, N30, well, we got four choices on the left there, 8, 10, 11, and 9, so it's going to be one of those. Okay, so let's solve for n. First thing, let's subtract 6115 from both sides. Not my clearest writing, but you get the idea. We're going to end up with negative 8750 when we subtract those two. Now let's divide both sides by negative 875. Well, those numbers look familiar. Looks like it's going to be 10. So that's my answer right there. It's going to be 10. It's the 10th term. There's 10 terms in that sequence. Awesome. Okay, we're rolling. Moving along. Let's check out number 4. Number 4 is actually a pretty quick one. The 13th term is 8. The 17th term is 8. What's the 25th term? If this is a arithmetic sequence, it looks like the numbers don't change. So that would mean the common difference is 0. If it's a geometric sequence, the numbers don't change. So that would mean the common ratio is 1. You multiply by 1 each time and it doesn't change. Either way, it doesn't change. So our 25th term, it's also going to be 8. Number 5. 10th term is 243 times larger than the 5th term, and we know it's a geometric sequence. What's our common ratio? This one's a little tough. So we say, okay, what do we know? Our 10th term, well, these are all pretty tough, actually. That's the point, is that we want to struggle a little bit. Our 10th term, we say, is 243 times our 5th term, right? Our 10th term is 243 times larger. So to make them equal, we need to multiply our 5th term by 243. That's the only way to make them equal. 10th term is 243 times larger, so if we multiply the other one by 243, they should be equal. Okay? And so here's what we're going to say. To jump from term 5 to term 10 in a geometric sequence, How many jumps is that? We're starting at 5, and we're going to go 6, 7, 8, 9, 10. That's 5 jumps, right? 5 jumps. So we're going to multiply by our r value, whatever it is, 5 times. Or we can write that as r to the 5. And when we multiply by our r value 5 times, we end up with a number that's 243 times bigger. So whatever r is, when we multiply it by itself 5 times, we end up with 243. So what's that going to work out to? Well, you may have a button on your calculator that can do this, where you can choose the root number. There's a square root, there's a cubed root, and there's one that might look like this, where you can like choose a number for the number of roots. So you'd say what number times itself 5 times gives us 243. But you may not have that, so let's just do guess and check. Let's just do a guess and check. So we'll say some number to the 5 equals 243. Let's try 2 to the 5. It's 32. So no, that's no good. Let's try 4 to the 5. It's 1024. So that one's no good. Let's try 3 to the 5. It's 243. Oh, so there it is. So if my common ratio is 3, I multiply by 3 5 times to go from my 5th term to my 10th term. And that's why it's 243 times bigger, because I multiply it by 3 5 times. So what's our common ratio? It's 3. All right. That was a good tricksy one. Moving on to number 6. We're getting close to the end. We're almost there. We're only 11 minutes in. Wow, we're really moving. Okay, how many terms are there in this geometric sequence? So I did an example like this as one of the ones in class. We're going to need to figure out, I know this is term 1, this is term 2, etc. This is term n. I don't know what it is. We're going to have to figure that out. If we can figure that out, then we can, then we'll know how many terms there are, because it's the last term. Okay, so we'll say, what's our first term? Our a value, it's 2. It's a geometric sequence, so we're looking for a common ratio. What's our common ratio? Well, it looks like to get from 1 to the next, we multiply by 3. And what's our n value? We don't know. Let's do our general term. Here we go. Our general term is a times r to the n minus 1. That's not a great r. Let's fix that up a little bit. Let's sub in. A is 2, r is 3, to the n minus 1. So now what we're going to do is we're going to take this last number here, and we're going to substitute it in for our term, and then we're going to figure out an n value that we can sub in that will make that work. Okay, so we're going to need to figure out a number for n that will make this true. So 118,098. And that equals 2 times 3 to the n minus 1. So you can just start subbing in numbers for n and get it. But this is a little hard to sub into this. So why don't we like simplify our lives a little bit here? Let's simplify this equation. Let's divide both sides by 2 to get rid of this this 2 right here. So we'll divide both sides by 2, and on this side we're just left with 3 to the n minus 1. And this number divided by 2 is going to be 59,049. 4s and my 9s look really similar. Okay, so this is not so bad. So let's just try and do a little guess and check here. And let's see what value 3 to the something equals 59,049. So let's just try some numbers here. I don't know. Let's try 3 to the 8. 3 to the 8 is 6561. That's not it. We need a bigger number. Let's try 3 to the 10. That's going to be, 59,049. That's it. We got it. So 3 to the 10 is the one we want. Now here's the thing. If we move up here, we say, we really have an n minus 1 right here. So we'll say that whole thing's got to work out to be 10. So n minus 1 has got to be 10 to make that math work. So that means n has got to be 11 if we add 1 to both sides. Okay, so that's how many terms there are. There are 11 terms. All right. Rolling along here. I want to cross out number 7. This one is a bit too weird, and so if you tried your best on it, you're awesome, and give yourself a nice pat on the back, but we're not going to do that one. I'm not going to include that in your assessment, anything like that one. Let's try number 8. Oh, and let me know if you were able to, if you did number 7 and you didn't, and you worked it out okay, that's awesome. So let me know. But I'm not going to go through that with you because I don't want you to do that one in the end. Number 8, calculate the sum of the last 15 terms of this sequence. Now this actually appears really hard, but we can use some clever little ideas to make this easier. Here's what I'm thinking. These are our numbers, right? But we only want the last 15. So let's see just what we can figure out about this first. The first one I want to try and figure out is, do we know the common difference? Well, it looks to me like it's arithmetic. We know that, so we know it's going to be a common difference. It looks to me like it goes up by 19 each time. Okay, so it's climbing by 19 each time. Here's my little tip, though. Instead of thinking about this as shown right here, I want you to turn this backwards. And instead, we're going to think about a series that starts with 328, and then after that, we're going to go in reverse order. So instead of going up by 19 each time, it's going to go down by 19 each time. So my next number is going to be 309. And my next number after that is going to be 290. And that's continuing on. Now this we would find much easier. This is the thing as a common difference of negative 19. It's going down by 19 each time. And our first term, our A value, is 328. So that's my tip for this, is think about it backwards. Start with the 328 and think that we're going down by 19 each time. And we're going to add up the first 15 terms of that sequence. That's a much easier problem to solve. So now that we've got, and now we're going to need our n value as well. Our n value would be 15 because we'd want the first 15 terms of this new flipped sequence. So we can actually just use our sum formula to calculate that, right? So our sum formula for an arithmetic sequence looks like this. Oops, square brackets, over 2. Let's sub in. So we got 15, 2 times 328, plus n minus 1. N is 15, so I can put that in. And our common difference is negative 19. All of that over 2. Let's get rid of the 15 and the 2. 15 divided by 2 is 7.5. So we got 7.5, and then 2 times 328 is 656. 15 minus 1 is 14 times negative 19. Fourteen times negative 19 is going to be negative 266. So we finish up in the brackets, we subtract those, we multiply by 7.5, and we're going to get 2,925, which is right here. So, cool little trick there. You can, instead of thinking about the last 15 terms of this sequence, flip it around, and now we're thinking about the first 15 terms of this reversed sequence, where instead of going up by 19 each time, we're going down by 19 each time. And that makes it a much simpler problem for us to solve. So a little trick there. Here's our last one. We're almost done. This one says, calculate the sum of the first 7 terms of the geometric series with first term 2 and fourth term 250. So we know it's a geometric series. We also know the first term. We don't know our common ratio. We do know we're calculating 7 terms. And we know our fourth term is 250. So that's all the stuff we know or want to know. Let's try our general term. Okay? So our general term is going to be a r to the n minus 1. A is 2. We don't know r. Now we can actually take our fourth term. Let's do that in a lovely royal blue. Let's take our fourth term and let's sub that in for here. And we're going to sub in a 4 everywhere we see an n. Okay? So our fourth term is going to be 250 equals 2 times r to the 4 minus 1. So everywhere we saw an n, we put in a 4. Okay, so far so good. Let's divide both sides by 2 to get rid of that 2. So it'll be gone from here, and this will be 125. I should have just simplified that to r to the 3. So now we need to find some number that when times itself 3 times gives you 125. You might just know what that is. You might also have a button on your calculator that says this. It's got a cubed root. It's like taking a square root, but it does some number times itself 3 times. The answer is going to be 5. Now you could get that just by guessing and checking, saying what number to the power 3 gives us 125. You could figure out that pretty quickly that it was 5. So that's our r value. We're multiplying by 5 each time. So we're starting with 2, and we're ending up with 250. We're multiplying by 5 each time. Now we got to find the sum, right? Because that's what this question is really asking us. So let's do it. We have all the information we need. Geometric series sum formula looks like this. Not my best writing, but you get the idea. Let's sub in. Our a value is 2. Our r value is 5. Oh, and we can sub in for n because we're looking at our first 7 terms, right? In this case, we want to find our first 7 terms. Okay, so I subbed everything in for finding the sum of the first 7 terms. 5 to the 7, if you plug that into your calculator, you get 78125. 5 minus 1 is 4. So it's going to be 2 times 78124 divided by 4. We work that out. We get 39,062. That's our sum of the first 7 terms. Hey, that's one of the answers on there. Cool. Okay, I hope this has been helpful. These are some pretty challenging problems. And, you know, giving it a try and just working through and wrestling with that bear is going to make you a better math student. This is what we want to do, is we want to challenge ourselves. So hopefully you had a really good challenge with those problems, and I hope these solutions helped you out. Good luck in your studying tonight, and I'm looking forward to seeing you tomorrow. Bye for now.